Okay, after defining the location of geometric and shape of them, we should enter the flow simulation and set boundary condition. You know, HEC-RAS is a numerical model and requires boundary condition values to start simulation. For entering flow values, you should go to Edit menu and select Steady Flow Data. You know, HEC-RAS can simulate a flow in a steady and unsteady format or conditions. And in this part, we will select steady flow data. And in the next part of this course, you will learn how can you use unsteady flow data part. Okay, I will select steady flow data, and in this window you should define the number and the value of flow values. You know, HEC-RAS can simulate about 3000 water surface profiles simultaneously, but in this course, in this section, we want to enter 3 different flows and simulate the hydraulic property. For example, I will enter 3 parameters, 3, and select apply data, and you can see PF1, PF2, and PF3. These are the number of peak flood values. And you know, HEC-RAS consider these values for the upstream cross section. I mean, HEC-RAS will enter the flow values from the upper cross section into the model. Okay, for changing the PF1, PF2, and PF3 values, I will go to options and edit profile names. Excuse me. And I will remove these names and enter my values. For example, Q underline 10 CMS, Q underline 20 CMS or cubic meter per second, and finally Q underline 50 CMS. These are the values of flow. Okay, you can see the profile names is changed. Okay, I entered 3 different flow values, 20, 50. Okay, save the flow data like geometric flow data. Okay, we almost did all tasks or steps, but before start to running the model, you should enter the boundary values for boundary condition. You know, HEC-RAS consider different external boundary conditions type. You know, known water surface, critical depths, normal depths, and rating curve. In several case studies and several river studies, we don't have enough data sets to consider the boundary conditions. For example, rating curves require a hydrometric station with observed water surface elevation and flow discharge. Critical depths, you should have an drop structure at the end of the study reach. A non-water surface, you should like rating curve, you should have a water surface for specific flow values. If you know, in most case studies, we don't have observed data sets for use in boundary condition, and therefore we use normal depths. What's the normal depths? Normal depths consider that the water surface profile slope is equal the bed slope. In other words, the model assumes that there are uniform flow conditions in upstream and downstream, and this is logical and significant. Logical condition or assumption. Okay, as you know, the bed slope of this compound channel is 1 per 1000, and I will enter these values for normal depths. Enter the downstream slope for normal depths computation for each. Okay, and I will enter these values for both upstream and downstream of the study reach. We don't have enough information about this case study, and therefore we should input upstream and downstream boundary condition. If you know that the river is mild and always the fluid number is lower than 1, you can only enter downstream value. And if you know that the river is the slope of the river or channel is higher and it leads to fluid numbers higher than 1, you can only use downstream. If you don't have which of them is maybe occurred in your case study, you should enter both boundary conditions. Okay, I will save and close the window and back to the main window of HEC-RAS. Okay, we did all required process or steps for a steady flow simulation, and in this step we should run the model. For running the model, you can use run and select steady flow analysis, or select this icon, perform a steady flow simulation. Both of them are the same. Okay, when you select this item, you can see this window. In this geometry file, you can choose your geometry file. In a steady flow, you can choose your flow data. We don't have any model in this case, and therefore the model automatically select the input files we created before. Okay, in flow regime, as I told you before, when you assure that your river reach is in subcritical or supercritical condition, you can select one of them. If you select supercritical, you should enter the upstream boundary condition. If you use subcritical, you should, if you select subcritical, you should enter the downstream boundary condition. If you select supercritical, you should enter the upstream boundary condition. And if you don't have which of them can be occurred or can be exist in your study, you can use mix. This helps you model in which section, in which cross section the fluid number is lower 1 or is higher than 1. The formula or the hydraulic formula is different for supercritical and subcritical, and the model automatically select when fluid number is lower than, switch to subcritical formula, and when the fluid number is higher than 1, model automatically switch to supercritical formula. And finally, we take the flood plain mapping, and this is not important in this part. For natural rivers, this can be checked. Okay, for better simulation, you can save your simulation as a plan. I save a file menu and select save plan and name it plan underline base. And also you should enter a unique ID for your model. I will enter base later. And in plan description, you can require this description about your projects. For example, this is a steady flow simulation in a compound channel. Okay, I will press compute and the model starts to run. If there is a problem in the flow data, in the boundary condition, or in the cross section, it will be shown in this part. As you know, this is completely natural for river modeling. Okay, fortunately in this case we don't have enough error and model is completely ran. Okay, in this section that shows it's take about 8 seconds for running this model. Okay, after running the model you can use the graphical and tabular outputs and see your outputs. For example, we start the outputs from cross-sectional profile, other general profile plots, rating curves for each cross-section, and 3D multiple cross-section plot. This is completely schematic, and this part for anesthesia simulation and detail or summarize output tables. Okay, let me check from the first one. Moreover, you can use view menu and select these parts, or you can use these items to see the outputs. Okay, for capturing the water surface profile in each cross section, you can use cross section icon. Okay. Okay, in this figure you can see the water surface elevation, the water surface level in the upper cross section. Okay, in order to add different flows, you can right click on this figure and select profiles, and in available profile you can select all of them, select all, and then press OK to see the water surface elevation for each flow. Okay, you can modify the color of these lines, right click on the figure and select line and symbol, and in this window you can change the width of lines, symbols, and type of the lines. Okay, I select this value for width, this color for, and noun symbol, and let me green, and noun. Okay, also you can change the color of ground cross section, also for water surface. Okay, you can see the elevation of flow in a cross section, and you can go to the down lower river station, and as you can see the bed elevation is going down, and this is completely okay. Okay, there are some settings in order to better represent the output. For example, you can right click and select font size and select the font of first line caption, second and third line caption, legend, access label. For example, I said 24. As you can see, the font size of these axis is increased. Okay, let me select these numbers. Okay, also you can right click and select grids and untick these parts. If you can, if you want to see grids or not, you can check or uncheck these parts. Moreover, you can use velocity distribution. For example, I want to see, okay, let me select 50 cms, right click and select velocity distribution. And when you select plot velocity distribution, you can see the variation of flow velocity from in the cross section from left to side. Okay, you can set other values, for example, minimum velocity values, maximum velocity, and interval increments. Okay, in this example, I will enter 1, and the maximum value I think is about 24, and the increment interval can be about 40. Okay, there is not difference between the velocity values, and therefore most of the channel parts represent a unique and about 2 meters per second. Okay, you can unselect and show the water surface for different parts of the cross section. Okay, you can set different variables, for example, energy, grade line, critical depths. Okay, you can set, this is water surface and this is energy grade line. As you know, energy grade line equals the elevation of water surface and the head of velocity. And this difference, in order to measure the distance, you can select control in your keyboard, and this icon will be appeared, and you can click from the up and down and up, and then leave the control. Okay, in this figure, in this table, you can see the velocity head is about 26 centimeter, and the water depths, I take control and the water surface, and then leave the keyboard, leave the control button, and you can see the water depth is about 2 meter and 60 centimeter. Okay. Okay, let me uncheck the variables, profiles. Okay, these are water surface, and you can use these outputs in your reports. For example, you can go to file and select print, or copy plot to clipboards to copy these shape into your Word report or other formats. In the print multiple, you can use all cross section in the PDF file. I want to create an output in 30 number of across and 30 number of down. Okay, press OK. Okay, I should press print. And select the name CS. Okay, let me open in PDF environment. Okay, you can see the model automatically created all cross sections in a PDF format and in 3-page. Okay. The next step is to see the profile of water surface profile through the main channel, you know, for 10, 20, and 50 cms. You can see the water surface profile along the main channel. Okay, in this part you can right click and select line and symbol and define what color type, what line shape, and other parameters. You can click font size, or in landmark you can select river station name, and for each point you can see the name of river station. You can also copy to clipboard or print in PDF format, or you can export the output as a DXF and open it in AutoCAD or other related Autodesk softwares. Also, you can in this figure you can show the elevation of your banks. You should right click and in variable you can select left and right main channel bank elevation. You can see for this discharge value the flow is in the main channel, and for 50 cms discharge value the flow is increased and started to flow into the left bank and right bank. Okay, in the general profile plot you can see the variation of velocity, area, top feeds, or other important hydraulic properties through the channel for different flow discharge. You know, the shape of the channel is completely unique, and therefore the variation of velocity through the channel is the same from the upstream and downstream. And this is fruit number. However, this is the unique. Okay, in this figure you can see fruit X and fruit CHL. You should right click in this window and select plot variables, and you should choose which of them you want to see. I will remove the channel and I want to show you the fruit number for whole cross section. Okay, as you can see the value of fruit number range between, however there are so near to each of them, so close. Okay, you can select other discharge value and see the variation of fruit number along the channel for different flow values. For hydraulic depths, and you should most of the time you should right click on this figure and select plot variable and clear all of them, and in the left panel, you should select your desired and your hydraulic parameters. For example, hydraulic depth is the hydraulic depth of the whole channel, while hydraulic depth C is only for main channel, hydraulic depth L is only for left, and hydraulic depth only for right bank. And other hydraulic parameters in this figure you can select and show the outputs. Okay, I select the hydraulic, and other values. Okay, in this figure there's not any special settings. Most of them are similar to the previous windows. Also, you can use this copy to plot and paste them in your report. Okay, you can print in PDF format. Okay, one of the most important outputs of HEC-RAS model is the calculation of rating curve for each cross section. As you can see in this figure, you can extract the rating curve for each cross section. The rating curve is one of the useful tools for estimation of flood or discharge value based on water surface elevation. For example, if in a real case study you have a rating curve for a specific cross section in a river ridge, you can estimate the flood value based on observed water surface elevation. And HEC-RAS provides an environment to extract or calculate rating curves. Therefore, if you have rating curve for a specific cross section in a river ridge, you can easily calculate the flood values or the river values based on water surface elevation. For example, if the water surface elevation is equal to 8, I can continue this line and cross that the rating curve, and in the horizontal axis you can see the discharge value is equal about 30 cms. Okay, this is right click in this figure and select line, and therefore the number of the width of line and other color or other setting. Okay, you can check minor and major thick grid lines to show better. Okay, you can select copy plot to clipboard or print multiple or print separately for each cross section, or write rating curves and send them to the AutoCAD or DXF format. And finally, after finishing and reviewing the graphical output, you can use tabular data to see the hydraulic values for each cross section. In HEC-RAS, you can see the tabular output in two formats: details and summarize or summary output. For example, in detail output, you can see the hydraulic parameters for each cross section, for each river station, for each river profile. For example, I want to see the hydraulic properties for 50 cms. I select 50 cms, and in RS or river station, I can select my desired river station name For example, 10.5. You can see energy grid line elevation for this cross section, velocity head, and you don't need to calculate hydraulic parameters manually. The model computes all of them automatically, and you should only select the profile and your river station to see the hydraulic values. Okay, all of hydraulic parameters are sorted in these tables for LOB, for channels, and for right OB. Okay, you can select other profile. As you can see, for 20 CMS, we don't have, the model didn't calculated hydraulic parameters for left OB or right overhang because the water surface does not exceed from the elevation of banks. You can see for 20 centimeter, the flow or water is only concentrated in the main channel and don't exceed from the bank station elevations. Okay, you can select copy to clipboard, and select Excel or other spreadsheet softwares and paste these values, and also you can go to the Word and paste them in your reports. Okay, let me to load Excel spreadsheet. Okay, in this part I will select paste, and you can see the hydraulic properties of your simulation. Okay, you can arrange them and create borders and then copy them. Paste special, and I will insert that as a picture. Okay, that's just this. Okay, for summary output, you can select view summary output tables by profile, and also in this figure you can choose which output you want to see or you want to create outputs. As you can see from the options, you can select profiles, select all, and for each cross section the model sorted the hydraulic properties for each flow values, and you can select only one profile, and these columns can be completely customized. Okay, how can we customize these tables? It's only you should go to options, menu options, and select define table, and in this table you can delete all columns, and in the lower section you can select which hydraulic property do you want to show. Okay, I click in second column and go down and select, for example, velocity or hydraulic depths. Hydraulic depths for cross section. Double click and it will be added to the second column. After that, select column 3 and select other hydraulic parameter you want to show. Okay, let me show velocity or top width. Better to show top width. Top width of the water cross section. These are the main or important hydraulic parameters that you should create it for each study. Velocity channel, velocity, total velocity. Average velocity of flow in a total cross section. Okay, let me select fruit number, select column 5, fruit number for the entire cross section. Okay, I think that these are enough. Okay, press OK, and you will the summarize table with the specific and customized column. Okay, you can save this format for other project. In options, you can select save table, and I will name it my table format. Okay. In the user table, you can see my tables and other table I've created before. Okay, you can completely transfer these tables to your report or other where. Okay, copy to clipboard, data and headings, paste, and you can see the table and you can rearrange that or remove other unnecessary columns or labels. Okay, and then you can select all of them, copy, and then go to the Word, paste special, and select picture enhanced meta file. Okay, this is table for hydraulic properties for different river stations, and this is hydraulic property table for a specific cross section, not all cross section. Okay, finally, you can see the output in a 3D schematic format. Excuse me for the mouse sound. Okay, in the XYZ perspective plot, you can rotate or change the shape or rotation angle. You can zoom and you can rotate the channel and see the perspective. This is not a 3D model. HEC-RAS is a 1 and 2D dimension, not 4D. This is only for perspective plot of cross section and water surface, not for 3D dimension modeling. Okay, using these tools you can rotate or change the azimuth angle. For natural rivers, we can use these tools for better representation of flood variation through the river. Okay, I think these issues and these outputs is enough for this section. In the next part, for real river reach, we will investigate more outputs of HEC-RAS and better representation formats. I hope have a good time and enjoy hydraulic simulation using HEC-RAS. Bye bye.